Hello, and welcome to our lesson on understanding how to find the center of rotation given a figure and its rotated image. In this lesson, we'll build on your existing knowledge of rotations. Our primary focus will be on finding the center of rotation, a crucial skill when working with transformations in geometry. First, we'll start by reviewing the basics of rotations to ensure we're all on the same page. We'll reintroduce the concept of the center of rotation and explore why it is significant. Then we'll practice finding the center of rotation given a figure and its rotated image. Finally, we'll apply our new knowledge to various examples to solidify our understanding and explore how spotting the center can simplify complex problems. So how does this lesson build on what we have learned so far? Well, in our previous lessons, we've established a strong foundation by discussing and practicing rotations. You're already familiar with how to rotate figures around a point and understand the basics of rotational transformations. With this solid foundation, we are ready to delve into finding the center of rotation. This technique is fundamental in geometry and has various practical applications. For instance, let's imagine you have a shape that has been rotated and you need to recreate this transformation or understand the mechanics behind it. Knowing how to find the center of rotation allows you to describe and analyze the movement accurately, making it easier to solve problems involving rotations or to apply rotations in practical tasks such as computer graphics or engineering. Let's get started on this fascinating journey to understand and find the center of rotation. First, it's important to understand what we mean by the center of rotation. This is the fixed point around which a figure rotates. Identifying this point allows us to understand the transformation applied to a figure during rotation. Let's start by considering a foundational idea, corresponding points. These are points on the original figure and their images after rotation. For example, if point A on the original figure moves to point A prime after rotation, A and A prime are corresponding points. With this, we can now look at the step-by-step process to find the center of rotation. With this, we can now look at the step-by-step process to find the center of rotation. Step 1. Identify corresponding points. Choose at least two pairs of corresponding points on the original figure and its rotated image. For instance, if you have a square ABCD that has been rotated to A prime, B prime, C prime, D prime, you will consider the points A and A prime, B and B prime. You could possibly also utilize C and C prime and D prime, but only two corresponding points are needed. Step 2. Draw perpendicular bisectors. Draw a line joining each pair of corresponding points. Let us start by connecting A and A prime. Then, for each of these line segments, draw the perpendicular bisectors. A perpendicular bisector of a line segment is a line that divides the segment into two equal parts at a 90-degree angle. Step 3. We repeat this process for B and B prime, drawing a line segment connecting them, then bisecting it. Step 4. Find the intersection. Finally, the point where these perpendicular bisectors intersect is the center of rotation. This point is equidistant from all corresponding points in the original and rotated figures. To find the perpendicular bisectors first, we need to find the midpoint of the 2 points. To find the midpoints of 2 points with coordinates x1, y1 and x2, y2, you can use the formula that the x-coordinate of the midpoint will be x1 plus x2 divided by 2, and the y-coordinate of the midpoint will be y1 plus y2 divided by 2. Let's work through an example to illustrate these steps clearly. Given those two triangles with points A, 3, 5, and a prime, 2, minus 2, B, 3, 7, and B prime, 4, minus 2. Let's find the center of rotation. Step 1. Draw the lines connecting A prime, and B prime. Step 2 is to calculate the midpoints of A prime and B prime. To find the midpoint of A prime, we need to do 3 plus 2 divided by 2 to find the x-coordinate of the midpoint. This gives us 2.5. We then add the y-coordinates together, so 5 minus 2, and divide this by 2. This gives us a y-coordinate of 1.5. Therefore, we have found the midpoint of A prime. We now do the same for B prime. For the x-coordinate, we add 3 and 4, then divide by 2 to find 3.5. For the y-coordinate, we do 7 minus 2 divided by 2, which gives us 2.5. Therefore, we have found the coordinates of the midpoint of B, B'. Step 3. Draw perpendicular bisectors through these midpoints. These bisectors will be lines that intersect the respective segments at a 90-degree angle and pass through the midpoints. Step 4. Finally, locate the intersection of these perpendicular bisectors. The point where they intersect is the center of rotation. In this case, it is -1, 2. You can follow a similar process to solve any problem needing identification of the center of rotation. Understanding these steps and practicing with different sets of points will make the process intuitive. To reinforce this method, let's consider another practice problems. Given a rectangle with points P, 1, 1 and P, 2, -2, Q, 1, 4 and Q, 5, -2, draw lines connecting PP and QQ. Find the midpoints of PP, which is 1.5, -0.5, and the midpoint of QQ, which is 3, 1. Draw the perpendicular bisectors through the midpoints at a 90-degree angle. Finally, find the intersection between your two perpendicular bisectors, which is your center of rotation. In this case, the center of rotation is 0, -1. By practicing these problems and understanding each step, you will become proficient at finding the center of rotation for various figures. In today's lesson, we explored how to find the center of rotation given a figure and its rotated image, a key concept in transformational geometry. We began by understanding that a rotation involves turning a figure around a fixed point, known as the center of rotation, through a specified angle and direction. To identify this center, we use the concept of corresponding points, points on the original figure that map to points on the rotated image. By drawing perpendicular bisectors of the segments connecting each pair of corresponding points, we found that these bisectors intersect at a single point, which is the center of rotation. Finally, we practiced this method through several examples, reinforcing the technique of constructing perpendicular bisectors and ensuring accuracy in identifying the intersection point. Understanding how to determine the center of rotation equips us with a valuable tool for analyzing and interpreting geometric transformations effectively.